In this problem, we need to transform the polar equation r equals to a times 1 minus cosine theta into its Cartesian equation or its Cartesian equivalent. So let us begin. Let's say if we have a point P with Cartesian coordinate x, y, then the same point P can be also expressed in terms of its polar form as r cosine theta, r sine theta. Meaning we can express x in terms of its polar coordinate as r cosine theta, and our y will be equivalent to r sine theta. So we'll be using this fact. Now coming to our problem, we have here r equals to a times 1 minus cosine theta. So if we take x and y value, so let's take x squared and add it to y squared, this will become equals to r squared. Fine. Now we will use our polar equation, which is given by r equals to a times 1 minus cosine theta. To convert it to a Cartesian equation, we'll replace the value of r with square root of x squared plus y squared. That means we are writing r in terms of its Cartesian coordinate, and this will be equals to a times 1 minus cosine theta. What is cosine theta here? If we use this equation, x equals to r cosine theta, then cosine theta becomes equals to x over r, and then we can replace the value of r with square root of x squared plus y squared. So this is the equivalent form of cosine theta. We will use this fact here. We have x divided by square root of x squared plus y squared. If we further simplify, all you have to do is multiply throughout with square root of x squared plus y squared. So that's going to give us x squared plus y squared equals to, we get a multiplied to square root of x squared plus y squared minus x. Now clearly in this equation we see there is no term that contains r or theta, which means we have successfully converted or transformed our given polar equation r equals to a times 1 minus cosine theta into its polar equivalent.